This is number 45 from section 10.2, and it says a particle moves on the circle, x squared plus y squared equals 1, so that its position vector at any time t greater than 0 is given by 1 minus t squared all over 1 plus t squared. That's the horizontal component. And then 2t over 1 plus t squared, that's the vertical component. Find the velocity vector. Well, this is our position vector, so we've got to, I give it to you as r of t, but we could call it, yeah, r of t. So this is x of t, and this is y of t. So those are your horizontal and vertical components. So we want to find the velocity vector, so we're just going to take the derivative of each of these. All right, oh, I wrote it over here, sorry. Excuse me. Okay. So the derivative of this is going to be a massive mess of a quotient rule. Low d high, less high d low, denominator squared below. Multiply out and go through all the simplification. Fun, right? So make sure you do that. This is what we end up with. And it looks like you could simplify that a tad. And we have the negative 2t squared and the positive 2t squared becomes 0, so we got negative 4t. All over this. So this is my x prime of t. And my y prime of t, that's the derivative here. Again, same thing, low d high, less high d low, denominator squared below. Low d high, less high d low, denominator squared below. Multiply out, and ends up with 2 minus 2t squared on the top, and we have the same denominator. So there's your velocity vector. Now, good question, letter B. Is the particle ever at rest? Justify your answer. Well, it would be at rest if it's not moving horizontally and vertically. In other words, if it's not moving either. It could be moving horizontally and not vertically, and it could be moving vertically and not horizontally. Or it could be moving both. But if it's not moving vertically or horizontally at the same time, then it's at rest. So if we look at these fractions, when can this fraction be 0? Well, the denominator of either of these would neither be 0, so it's only going to be 0 when the top is 0. So the top of this fraction will be 0 only when t equals 0. So it's not moving horizontally when t is 0. Vertically, it's not moving vertically when this top is 0. Well, that top is going to be 0. If I set this equal to 0, that's going to be 2t squared equals 2. So t squared equals 1. So at positive 1, t won't be negative. So the vertical motion will be 0 only at t equals 1. So that's two different times. So it stops horizontally at t equals 0. So it could just be moving vertically. And then it stops vertically at t equals 1. It's just moving horizontally. So at no time will both be 0. So it never stops. It's either moving obliquely or horizontally or vertically, but not still. Okay? And the last one, give the coordinates of the point that the particle approaches as t increases without bound. So we're just going to take the limit of each of these components and find out where it goes as t goes to infinity. Well, as t goes to infinity of this, again, we are using just our rational function rules. Here the highest degree is the same, so we just take a look at the ratio of the highest degrees, and that's just going to be negative 1 over 1, or just negative 1. So that's this limit. If we take this limit, we can see that the degree of the top is smaller than the degree of the bottom. So as t approaches infinity, this approaches 0. So there's your point. So just have to think about it. And it's not too hard if you think about it. So try to keep these in mind. Help you to acquire a good intuition on how to use these things.